in Capechi's Corner, we're going to look at solving linear systems using the elimination method. So when we're using the elimination method, we need to find the values for x and y, and we're going to do that by adding together the equations. So when I look at number 1, I notice that my x coefficients are opposite values, a positive 5 and a negative 5. Once I know that, I can see that I can add. That's going to zero out. I add together 3y and 5y, and I get 8y equals 16. Now I'm going to solve for y, and y is equal to 2. Now that's my y coordinate. I need my x coordinate. So I'm going to go back to either equation. I'm going to use my first equation, and I'm going to substitute 2 in for y. 3 times 2 is equal to 11, and I have 5x plus 6 equals 11. Bring that 6 to the other side, and I have 5x is equal to 5, so x is equal to 1. So my solution to the linear system, remember we write it alphabetically, is 1, 2. So what that means is if I were to graph these lines, if I were to put them in slope-intercept form and graph them, this would be the point of intersection, which is the solution to the linear system. Okay, let's look at the next one. Now I notice my variables are lined up in columns, but I notice that nothing will zero out when I add it. But I do see that I have positive 6y for both the first and second equation. So if I multiply one of the equations by negative 1, that would give me negative 6y, and that would help. So I'm going to do that first. So again, every term has to be multiplied by negative 1. I get negative 30. I'm going to rewrite my second equation. Negative 3 plus 5 gives me positive 2x. That's going to zero out, and I get negative 24. Divide both sides by 2, and I have x is equal to negative 12. I'm going to substitute into either equation. Doesn't matter which one. I'll do the second one. So I have 5 times negative 12 plus 6y is equal to 6. So I have negative 60 plus 6y is equal to 6. And then I have 6y is equal to 66, so y is equal to 11. So that gives me negative 12, comma 11, which is my solution to the linear system. Now, just as a reminder, like you did in previous lessons, if I want to check these answers, I can go back and substitute it into my original and make sure I get true statements. I'm not going to do that in this video since we have several examples, but again, you can pause the video and try that yourself. In looking at the next set of equations, I notice that when I add the equations, nothing's going to zero out. But I do notice that I have 10x and 5x. 5 and 10, they're multiples of 5. So I realize if I multiply this by negative 2, now look, if I multiply this by positive 2, that's not going to help me. That's going to give me positive 10. I want the opposite, which is negative 10. So I'm going to multiply it by negative 2. So again, I'm going to rewrite my first equation. And then I'm going to multiply the second equation by negative 2. And then I see what happens. That's going to zero out, which is what I want. And I have 11y is equal to 44. So y is equal to 4. I'm going to go back into either original equation. Doesn't matter which one. I'll do the first one. 10x plus 5 times 4 is equal to 30. So 10x plus 20 is equal to 30. And 10x is equal to 10. So x is equal to 1. So our solution to the linear system is 1, 4. Now, when I look at the next set of equations, I notice that if I add the equations, nothing's going to zero out. There's not a number that I can multiply by either equation to make a term zero out, a variable. So this time I'm going to have to multiply both equations. So I'm going to work with that y because I have a negative 2 and a positive 5. So I know the signs are opposite, and I know I want opposite numbers. So I'm going to multiply this first equation by 5 because 5 times 2 is going to give me negative 10. And I'll multiply the second equation by 2 because 2 times 5 gives me positive 10, and that's what I want, opposite numbers. So that gives me 15x minus 10y is equal to 190. Do the same thing with the second equation. That gives me 10x plus 10y is equal to 60. Now I can add because that's going to zero out. So I have 25x is equal to 250. So x is equal to 10. I'm going to use either of the original equations. Doesn't matter which one. I'll use the second one this time. I have 5 times 10 plus 5y is equal to 30. So 50 plus 5y is equal to 30. 5y is equal to negative 20. So y is equal to negative 4. So my solution to the linear system is 10, negative 4. Okay, moving on, I notice in number 5 that my variables aren't lined up. I have a y and an x there. So I have to make sure, I like to put them in standard form. I have to make sure my variables lined up. So when I add them, I'm adding the same variables. So what I'm going to do first with this equation is I'm going to bring that x to the left, and I'm going to put that equation in standard form. Then I'm going to rewrite what I have underneath, and then I'll evaluate at that point. Now I notice if I'm looking at my x's, I have a negative x and a positive 4x. So if I can make this a negative 4x, then I'll be able to zero out my x values. So that gives me negative 4x plus 4y is equal to 52. I'm going to rewrite that second equation underneath. 4x plus 14y is equal to 20. That's going to zero out, and I end up with 18y is equal to 72, so y is equal to 4. I'll substitute it back into my original equation. I'll use the first one, so y is equal to 4 is equal to x plus 13, so x is equal to negative 9. So my solution to my linear system is negative 9, 4. Okay, let's keep going. Now I noticed in number 6 that I can't add and eliminate a variable. So I'm going to multiply this second equation by negative 5 because I'm going to try to get positive 5x and negative 5x. So I'm going to rewrite my first equation, multiply everything by negative 5. I get negative 5x plus 15y is equal to negative 25. Now you'll notice on this one, when this happens, something different has happened. So this is going to zero out. That's going to zero out. So my left-hand side, I have a 0. On my right-hand side, I also have 0. So what this is, I don't have a value for x or y. So we're just going to say this is a true statement. Doesn't matter if it's 7 equals 7 or 0 equals 0. We have a true statement. And what that means is we have infinite solutions. There's going to be a variety of solutions that works. And if you remember from our previous lesson, that if I have one line and I were to draw another line right on top of it, they're going to touch an infinite number of times. So when we have that, when it's the same line, that's when this is going to happen, when we get a true statement with no variable. All right, let's take a look at our last example for today. Again, I noticed my first equation is not in standard form, so I'm going to bring over that y. And I'm going to rewrite my second equation. And I'm going to multiply the top by negative 3. So I get negative 3x minus 3y is equal to negative 12. I'll rewrite my equation underneath. X is 0 out, y is 0 out. So on the left-hand side, I have a 0. This time on this side, I have negative 2. So 0 does not equal negative 2, so that is false. So what that means is there's no solution to this linear system. And when we get that is when we have parallel lines, right? Parallel lines don't touch, so therefore they don't have a solution. Okay, thanks so much for stopping by. Have a great day.